Are you familiar with Chiplets? Should you be? That's where Rich and Vin go in this installment of DevTalk with Rich and Vin. Welcome to DevTalk with Rich and Vin. I'm Rich Nass, Executive Vice President of Open Systems Media, and I lead the embedded computing design team. And that guy on the other microphone is Vin D'Agostino, who is the guy who answers my questions. Whether he knows the answer or not, he makes up answers, and I don't know the difference. So we're going to assume that they're true. How you doing, Vin?
Good. How are you, Rich?
I'm doing just fine. Thank you very much. So topic du jour, I need a little education here. Everybody's talking about chiplets. What's a chiplet?
Everybody's talking about chiplets. So chiplets are basically ICs that have been put together with some building blocks at a higher level than they're doing now. I mean, if you go to any semiconductor company, let's say it's an MCU company, they have A to Ds, they have D to As, they have timers, they have UARTs, and they have, some logic and or compute engine and memory. They aren't redesigning every one of those for every chip, right? They already have a library and they have their favorite 12-bit A to D or their favorite three-phase timer for doing motor control. But it's very much in their library, and the interface between that and the rest of the chip is pretty defined for that particular family of design. So if you had, let's say, 3 different families of MCUs, the interface on a UART might change depending on which family you're using. The chiplet, I hate to even say this because then the software guys will say we won, but it's almost like having an object that is hardware, right? And it also allows you to potentially create lower volume and more flexible designs. And it is fun and it's new, but it's kind of not really that new too.
Is it similar to a multi-chip module?
Well, it's funny you should bring that up because that was the kind of example that I was going to use. If you look at building any kind of product, you've got technology, you've got process, and you've got manufacturing. And any one of those 3 innovations can bring the product forward. And those 3 things can sort of play off each other to continue to bring forward. The example that I would use back in the 90s-ish, let's say early 90s. Some of our listeners are actually old enough to remember the 90s. When you wanted to make a modem, you had to buy 3 chips. They were 3-chip modems, and that was it. And they were not difficult to design with, but certainly not easy to design with. And let's also go back to the fact that most people were not designing PC boards in a computer at that time, right? It was
what were the 3 chips?
So there was the analog front end. God, I knew you were going to ask me that. I should have looked up the 3 chips. There's the line interface, which includes the analog front end. There was the
our listeners can chime in with
the basic computing part, and then there was basically the glue logic. But yeah, anyone who worked in that, I actually joined working with modems when the quote unquote single chip modem came out. Okay. And at the time I had just started working for XR, and they had a 2-chip modem set because they had a mixed mode process, and they were able to integrate some of the analog with some of the digital stuff. That was one of the problems, is that the analog stuff had a certain voltage, right? Because your phone line and all that, the digital part was a different voltage. The chip was going to be too expensive because if you made the feature size of everything big enough to deal with the high voltages. And so we had a 2-chip modem, and we thought we were really cool. And we actually only made the one of the 2 chips, and then you combined it with the compute engine of somebody else's chip. Rockwell, who actually made ICs back then, they made 6502 microprocessors, which is really, if you think back on that, they came up with what they called the single chip modem. It was one package you put on the board. Don't forget, people were laying boards out on acetate with Mylar tape and X-Acto blades. So, every trace you put down cost you a fair amount of time and money. It's not like now where you can just click and drag, right? everyone was shocked at how they could come out with a single chip modem. They were Rockwell. They weren't a semiconductor company. They had a semiconductor division to make some specialty parts that nobody wanted to make for them for their aerospace business. And then somebody popped the top and they realized that all they did was take the 3 chips and make a multi-chip module. They were at the pinnacle of IC manufacturing. And so instead of innovating in technology or in process, they innovated in manufacturing and made a single chip modem. And that is a big deal. This is
And you're
the
saying that
IC.
that's the same as the chiplet of today?
I was going to say
Back.
this is the on IC monolithic version of that philosophy. In this case, it was an innovation in process, right? How are we going to make the process innovation to be able to have people put these chiplets together and make a system on the chip, right? And you couple that with some of the manufacturing advancements that have been made where, there was a time where if you were a semiconductor company and you wanted to make a test chip, you had to buy a whole wafer. And now with mixed shuttles, you can actually have your die on a wafer with other people's die, and it runs through, and it's not costing you as much to run your test chips. So that is now an innovation in manufacturing. And of course, the innovation in technology would be things like feature size, circuit design, that kind of stuff, right? So you take those 3 things and you put them together and you innovate in one, which makes the product dramatically different for the marketplace. And that also allows you to capitalize on or force changes in other pieces of the puzzle to make things move further even or move forward even further.
So let me ask you a question.
Sure.
What's a chiplet?
Chiplets are the little pieces, the little modules that get put together. It's the chip version of an applet, right? It's not a full application, but it's a small part of an application that does one thing really well. This is a small silicon design that does one thing really well, has a defined interface that lets you snap together other chiplets and put a system together on the chip.
Okay, that actually makes sense.
And I would say that it is a combination of circuit and layout, because what's one of the other things, right? You can have circuit blocks and you put them together into a schematic, but now you need to lay them out on the chip, right? The chiplet has the layout with it. And so as you snap these things together electrically, you're also snapping them together physically to some extent, right? With anything, there's going to be limitations, but it lets you kind of say, I want 2 from column A and 1 from column B, and put this together and make me a chip.
So that means it's not being done at the die level.
I mean, ultimately, everything is done at the die level, right? I mean, communication has a media, even though you have a 7-layer model, it still has to go out the wires. So at some point, it is done at the die level, but the concept and design part is not being done at the chip level. It's being realized at the chip level once everything is synthesized together.
And how do I test this chiplet?
Well, there are 2 layers of design minimum for every one of these systems. There is the verification that each section works, and there's the verification that the overall system meets the design spec, which is kind of like a black box design. You have designed and spec'd some excitation and some result, and you run through that. Now, you have to limit it, right? If you say, hey, I have X amount of memory, it's going to take me forever to diddle every bit every way. And so, there are rules and criteria for figuring out a statistically significant subset of tests that makes you believe that the chip works, right? But you also have some specific function that you like, hey, if it was a thermostat chip that you built with chiplets, that by varying the temperature, you expect the output to turn on and off, right? That's a very simplistic viewpoint, but that's your ultimate black box design test. I go above the set point and it turns off. I go below the set point and it turns the heat on, right? There's obviously display and all other kinds of things, but that's the...
Is this something for the long term, or is this a short-term fix that'll be displaced by something else? And that's a crystal ball question.
I think it'll always be a piece of the long term, but I think it's going to lead us to something that that pushes the design even closer to the system designer and not the chip designer. So I think this is a step in a process. It might remain a step in the process for a long time. But I think it is not, this isn't the holy grail, like this is where we're going to stay forever, right? It's not quite as bad as when they started talking about streaming and it was really a bunch of guys running around at the home office putting tapes and VCRs that were targeted to your house, right? That was a short-term solution to streaming. But it is definitely going to be part of the process for a long time, but it won't be the long-term solution, I don't think.
Okay, sounds good. I'm going to dive into it a little further. Maybe I'll have something to come back on this subject.
Maybe some of our listeners or readers can give us some examples of things that they've done or they're thinking about doing, and we can maybe even put together a little roundtable with some manufacturers who are playing with chiplets and ask some deeper questions.
That would be pretty cool. Thank you, Vin. That was Vin D'Agostino. I'm Rich Nass, and this was Dev Talk with Rich and Vin.